Saturn is tilted at an angle that shouldn't exist, wearing a set of rings that are far too young to have been there since the planet formed, and orbited by a small, oddly shaped moon that tumbles through space in a way nothing else in the solar system does. For years, those three facts sat in scientific papers as three separate, unconnected oddities. Now a team of researchers is arguing they're actually the same story, the leftover wreckage of a collision between two entire moons, one of which doesn't exist anymore. Stick around, because I'm going to walk you through exactly what NASA and independent researchers have pieced together about Saturn's missing moon, why its disappearance may explain some of the biggest open questions about the planet, and why this idea has been evolving rapidly over just the past few years. And if you want more of these deep dives into real published research instead of recycled headlines, go ahead and subscribe now, because there's a lot more coming out of the ring giant of our solar system. To understand why this particular mystery took scientists so long to even notice, you first need to understand the specific clue that started the whole investigation: Saturn's tilt. Saturn's spin axis is tipped over at roughly 27 degrees relative to its orbit around the Sun. A tilt similar in scale to Earth's own 23-degree tilt, responsible for Earth's seasons. On its own, that wouldn't be strange at all. Plenty of planets have some degree of axial tilt. What caught researchers' attention was a very specific coincidence buried in the physics of that tilt. Saturn's axis wobbles slowly over time, a motion called precession, and the rate of that wobble sits remarkably close to a specific orbital frequency associated with Neptune, far across the solar system. That kind of alignment between two planets' motions doesn't typically happen by accident. It usually indicates what astronomers call an orbital resonance, a stable, mutually reinforcing gravitational relationship that develops and locks into place over enormous stretches of time. William Hubbard, a professor emeritus of planetary sciences at the University of Arizona, who wasn't involved in this specific research, has described the situation almost musically, comparing Saturn's various spins and orbital rhythms to an intricate clock, with different components ticking along at their own distinct frequencies. Saturn wobbles at a rate suspiciously close to a fundamental frequency of the broader solar system, Hubbard has noted, but not quite precisely in tune with it, and that small, persistent mismatch is exactly the kind of clue that suggests some sort of relatively recent disruption knocked the system slightly out of a cleaner, more exact alignment it likely held at some earlier point in its history. The problem was that Saturn's match with Neptune's frequency wasn't quite exact. It was close, suspiciously close, but not the precise, clean lock astronomers would expect from a genuine, currently active resonance. That small but real mismatch became the thread that eventually unraveled everything else. In a study published in the journal Science in 2022, MIT planetary scientist Jack Wisdom and his colleagues proposed that Saturn had once been in a much more exact version of that same resonance with Neptune, locked in for potentially billions of years, and that something specific had knocked it loose relatively recently in geological terms, leaving behind the imperfect, slightly off echo astronomers still measure today. If you're finding this as fascinating as researchers clearly have, drop a comment and let me know, because it genuinely helps me figure out what other space stories are worth covering next. Wisdom's team ran detailed computer simulations to figure out exactly what kind of disruption could break a resonance that precise, and their answer involved a moon that no longer exists. They proposed that Saturn once had an additional satellite, roughly the size of Iapetus, one of Saturn's mid-sized moons today, and gave it the name Chrysalis. According to their model, Chrysalis orbited Saturn for billions of years, contributing its own gravitational influence to the resonance with Neptune, until Saturn's much larger moon Titan, slowly drifting outward over time the way large moons often do, gravitationally disturbed Chrysalis badly enough to knock it into a chaotic, unstable orbit. Sometime between roughly 200 and 100 million years ago, that instability sent Chrysalis spiraling close enough to Saturn that the planet's gravity ripped it apart entirely. And breaking that satellite's presence out of the system was, according to the model, exactly what caused Saturn to fall out of its precise resonance with Neptune, explaining the tilt seen today. As an added bonus, the same disruption that destroyed Chrysalis conveniently explained a second long-standing mystery: Saturn's rings had already been shown, through data collected by NASA's Cassini spacecraft, to be surprisingly young, potentially only a few hundred million years old rather than as ancient as the planet itself. And Wisdom's team proposed that the shredded remains of Chrysalis were exactly what became those rings. Wisdom himself has spoken about why this particular explanation felt so satisfying once his team worked through the math, describing his own reaction in terms of how many separate puzzles it managed to connect at once. He's noted that the scenario ties together things that were previously not thought to be related at all. I'm pointing out that nobody had previously guessed the rings and the planet's tilt might share a common origin, let alone that both could trace back to the disappearance of a single satellite. That kind of unexpected unification, tying multiple seemingly unconnected observations together through one underlying cause, is exactly the sort of result that tends to generate serious scientific attention, even when, as in this case, the proposed culprit is something that no longer exists and therefore can't be directly observed or confirmed through any future telescope observation. That original 2022 proposal was elegant, tying together the planet's unusual tilt and its suspiciously youthful rings with a single missing moon. But it left at least one thing unaddressed, according to a separate researcher, who took a fresh look at the same underlying puzzle a few years later. Matija Čuk, an astronomer, at the SETI Institute, approached the mystery from a different angle entirely, starting not from Saturn's tilt, but from one of its stranger existing moons, Hyperion. Hyperion is a small, porous, oddly shaped body that tumbles chaotically through space in a way genuinely unlike any other large moon in the solar system, and Čuk had previously calculated, based on its current orbital relationship with Titan, that Hyperion must have settled into its present arrangement sometime within roughly the last 400 million years, a time frame that lines up suspiciously well with when Chrysalis was supposedly lost. Čuk's reasoning was straightforward once laid out. If Hyperion's specific orbital lock with Titan only formed a few 100 million years ago, that timing is a more direct signal of when something disruptive happened in this part of the Saturn system than the tilt itself is, and it deserved to be woven into the same explanation rather than treated as a separate coincidence. Working with colleagues including Jim Fuller and Valerie Laney, Čuk built new simulations, testing what would actually happen if an extramoon, roughly 4 times more massive than the original Chrysalis proposal, a body Čuk began calling Proto-Hyperion, interacted not just with Saturn's gravity, but directly with Titan itself. The results genuinely surprised the team. In the overwhelming majority of their simulation runs, this extramoon didn't get torn apart in a close grazing pass by Saturn's atmosphere the way the original Chrysalis model proposed. Instead, it collided directly with Titan and merged into it. Čuk described the object bluntly, calling it Proto-Hyperion, but noting it was roughly 1,000 times larger than the moon Hyperion is today, essentially a smaller companion version of Titan itself. According to this refined model, Titan survived that collision largely intact, absorbing most of the impacting moon's mass, while a portion of the debris, kicked loose by the impact, gradually came together to form the present-day Hyperion, explaining both that moon's strange, porous, tumbling nature and its unusually tight orbital relationship with Titan in one connected event. That single collision, if the model holds up, would elegantly account for several previously unconnected oddities at once. It would explain why Hyperion looks and moves the way it does, rather than resembling a typical, smoothly rounded moon. It would explain why Titan's own orbit has been slowly drifting outward from Saturn faster than simple tidal models alone predict, since a direct impact from a large companion moon could have altered Titan's orbital momentum in exactly the kind of way needed to produce that observed drift. Čuk has suggested the same violent event might even help explain some of Titan's own surface characteristics, including its distinctive lack of large, obvious impact craters and questions about its atmosphere, since a direct hit from an object, a smaller version of itself, could plausibly have reshaped its outer layers or contributed to atmospheric loss in ways scientists are still working through. It's worth explaining a little more carefully why Hyperion's specific characteristics served as such a compelling clue in the first place. Unlike nearly every other mid-sized moon in the solar system, which tend to be either roughly spherical or locked into smooth, predictable rotation, Hyperion tumbles chaotically, its orientation constantly shifting in a way that's genuinely difficult to predict far in advance, even with precise modern orbital mechanics. It's also unusually porous and irregularly shaped, more like a loosely bound pile of rubble than a solid, coherent body. Those two traits together, chaotic, tumbling, and a porous, irregular structure, are exactly the kind of signature researchers would expect from debris that came together relatively recently and relatively violently, rather than a moon that formed smoothly alongside Saturn billions of years ago and has simply settled into a calm, predictable orbit ever since. That combination of clues is what led Čuk to treat Hyperion not as a strange but unrelated curiosity, but as the single, most direct piece of physical evidence pointing toward a genuine, relatively recent collision somewhere in this part of the Saturn system. There's a genuine, ongoing scientific disagreement buried inside this story that's worth being upfront about, because it's not simply a case of one team confirming another's earlier work. Wisdom's original 2022 model and Čuk's more recent proposal don't fully agree with each other on the specific fate of the lost moon. Wisdom's version has it grazing Saturn's cloud tops and being torn apart directly by the planet's own gravity, with the debris then forming the rings. Chuck's simulations instead suggest the far more common outcome is a direct merger with Titan rather than a destructive pass by Saturn itself, which raises its own question about where the ring material actually came from if the moon in question mostly ended up absorbed into Titan rather than shredded near the planet. Chuck has acknowledged this gap directly, suggesting that, if his version of events is correct, the rings might require an additional separate lost moon on top of Proto-Hyperion to fully explain their origin, rather than a single object accounting for everything at once. That kind of open disagreement between two serious, independently developed models is exactly the sign of a scientific question still actively being worked out, rather than one nearing a tidy, settled conclusion. Other researchers studying the same broader puzzle, including a separate 2026 paper from Wisdom himself, alongside colleagues, Rola Dibuk specifically examining the tidal stripping mechanism in more detail, have continued refining exactly how a moon-like chrysalis could have been pulled apart by Saturn's gravity in the first place, testing the physical plausibility of that specific step in the story with more precision than the original 2022 paper attempted. Meanwhile, additional theoretical work published in 2026, examining the broader Saturn-Neptune resonance question, has continued probing exactly how Titan's outward migration could have destabilized a satellite like Chrysalis or Proto-Hyperion to begin with, treating that piece of the mechanism as still worth independent scrutiny rather than settled fact. This entire story is also unfolding against the backdrop of Saturn quietly becoming the undisputed moon champion of the solar system, in a completely separate but genuinely related line of ongoing research. Astronomers using ground-based telescopes have continued discovering new, small, irregular satellites around Saturn at a remarkable pace in recent years, pushing the planet's confirmed moon count past 280 by early 2026, far ahead of Jupiter's own count. Many of these newly discovered moons are tiny, only a few kilometers across, and orbit at great distances from Saturn on tilted, elongated, often retrograde paths, moving opposite to the planet's own rotation. Researchers studying these small, irregular satellites have suggested that at least some of them likely originated from earlier collisions. Among Saturn's larger moons, fragments scattered outward during past violent events, potentially including the very same kind of catastrophic collision Chuck's team has proposed for Proto-Hyperion and Titan. Every additional small moon discovered adds one more small piece of physical evidence to a broader picture in which Saturn's moon system has clearly experienced significant collisional violence throughout its history, rather than settling peacefully into its current configuration without incident. It's worth pausing to explain why researchers find this particular explanation so compelling despite the remaining disagreements over the precise sequence of events, because a single missing moon accounting for multiple previously unconnected mysteries is genuinely unusual in planetary science. Wisdom himself, discussing the original proposal, noted that what made the idea appealing wasn't just that it explained the tilt or just that it explained the rings, but that it tied both puzzles together into a single coherent story, a connection nobody had previously suspected existed at all. Extending that same logic to include Hyperion's strange orbit and Titan's own unusual characteristics, as Chuck's newer work attempts, would represent an even more significant unification, explaining four or more previously separate oddities through a single ancient catastrophe, if the details can eventually be worked out to everyone's satisfaction. There's a broader context worth understanding here too, because this entire investigation has been made possible largely by one specific spacecraft's legacy. NASA's Cassini mission orbited Saturn for 13 years, from 2004 until it was deliberately steered into the planet's atmosphere in 2017 to avoid any risk of contaminating potentially habitable moons like Enceladus. Cassini's detailed measurements of Saturn's rings, its precise tracking of the orbits of Titan, Hyperion, Iapetus, and the planet's other moons, and its careful mapping of the subtle irregularities in Saturn's own spin and gravity field are what originally revealed the ring's surprisingly young age and the imperfect resonance mismatch with Neptune that kicked off this entire line of research in the first place. Every proposal discussed here, Wisdom's original chrysalis model and Chuck's more recent Proto-Hyperion refinement alike, is built on data. A spacecraft that stopped operating years ago is still generating new scientific insight from simply because researchers keep finding new questions to ask of the same archived measurements. That's a genuinely remarkable testament to how much scientific value a well-designed mission can continue producing long after its own operational lifetime has ended. Cassini's final act, a deliberate plunge into Saturn's own atmosphere, specifically to protect the potential habitability of nearby moons, has become something of a symbolic bookend to a mission that spent over a decade quietly gathering exactly the kind of long baseline, high-precision data needed to eventually notice something as subtle as a slightly imperfect orbital resonance. None of the moon collision theories discussed here would have been possible to even formulate without that sustained, patient observational record. built up gradually over Cassini's entire operational lifetime, rather than captured in any single dramatic flyby or headline-grabbing image. So what does all of this actually add up to? Saturn's unusual tilt, its suspiciously young rings, and one of its strangest, most chaotically tumbling moons may all trace back to a single violent event from the age of the dinosaurs, the destruction or absorption of an entire satellite that no longer exists in any recognizable form today. There's something genuinely humbling about a mystery this large hinging on an object that, by definition, nobody will ever be able to observe directly. Every other planetary science puzzle eventually offers at least the theoretical possibility of a future spacecraft flying past, a rover landing, or a more powerful telescope finally resolving the detail in question. This one is different. Chrysalis, or Proto-Hyperion, or whatever this vanished moon should properly be called, is gone, either ground into ring particles or absorbed entirely into Titan's own bulk, depending on which version of events eventually wins out. Everything researchers can ever hope to learn about it has to come from indirect evidence, subtle mismatches in orbital resonance, unusual textures on a small chaotic moon, ring particles that seem too young for the planet they surround, painstakingly, reconstructed backward through computer simulation rather than confirmed by any future direct observation. That's an unusual, almost archaeological way of doing planetary science, piecing together the biography of an object solely from the marks it left behind on everything around it before disappearing completely. Exactly how that moon met its end, torn apart by Saturn's own gravity as the original model proposed, or absorbed directly into Titan in a head-on collision, as the newer research suggests, remains a genuinely open and actively debated question, with real, credentialed scientists working from the same underlying data and arriving at meaningfully different conclusions about the precise sequence of events. If stories like this one, grounded in real published research and honest about where scientific disagreement still exists, are what you want more of, subscribe to this channel and turn on notifications, because researchers are still refining these models. And there's a real chance the next study finally pins down exactly how Saturn lost the moon that may have shaped so much of what we see when we look at it today. Thanks for watching, and I'll see you in the next one.